Well, hello. Welcome back to what is essentially the first week of this semester. We had that partial bit at the end of last week, but really we're about to start getting into the new stuff of the new semester. And what we're about to jump into is a unit on trinomials, quadratic equations. It's our quadratics unit. And we're going to be focusing mostly on factoring trinomial expressions. But today I thought before we jump into the meat of all that it's been a while since you've done any factoring. So I thought we needed a little bit of a refresher. And so we're going to go over some of the basics of factoring today and later this week. The first thing you want to do when we're talking about factoring an expression or an equation is to see if there is a greatest common factor. So we're going to start with the greatest common factor and how we go about finding that. Now, if I give you two numbers and I ask you to find the greatest common factor, say I have I want you to find the GFC, the greatest common factor of 12 and 16. Now, these are just numbers. It's really easy to pick apart the greatest common factors of 12 and 16 because we can just list all of the factors, right? If I have 12, I know that 1 times 12 equals 12, 2 times 6 equals 12, 3 times 4 equals 12, and that's pretty much it. Those are all of my factors of 12, right? I have 1, 2, 3, 4, 6, 12. All the factors of 12 are listed. If I look at 16 and I need all the factors of 16, I've got 1 and 16, 2 times 8, 3 doesn't go in, 4 times 4. And then we're pretty much maxed out on the factors of 16. So if we look at this, our factors of 16 would be 1, 2, 4, 8, because we'd already listed the 4, and 16. And we can look at this list of factors that we have and determine, well, what is the biggest number that they have in common? Now, they both share a common factor of 2, but they also both share a common factor of 4. And that is the greatest number that they share in factors. And therefore, their GFC, their greatest common factor, would be 4. And I know you guys learned this years ago, but it never hurts to review all of this because it's been a long time since you've done any kind of factoring, right? And so when we're talking about numbers, it's really simple to find the greatest common factor. But it's also pretty simple when we bring in variables. If I have x squared plus x to the 4th plus x to the 15th, right? I probably should have left that up. Let's make this x to the 9th just to save me a little headache. Ultimately, x squared is just x times x. X to the 9th, oh, sorry, that's x to the 4th. Look at that, I'm messing it up. X to the 4th is x times x times x times x. X to the 9th is going to be x times x times x times x times x. How many more do I need? 4? 1, 2, 3, 4. It's x multiplied by itself 9 times. So if I'm looking for the greatest common factor of this expression, right? If I need to find the GCF of this expression, I'm going to go, well, what do they all have in common? Well, this one has 2 x's, right? This one has 2 x's, and this one has 2 x's, right? It's the only thing that all 3 pieces of the expression have. And so our greatest common factor in this would be x squared. So if I need to factor this to its simplest form, factor out its greatest common factor, I would have, say I have x squared plus x to the 4th plus x to the 9th. Its greatest common factor when I factor something out would be x squared is what I'd pull out. X squared divided by x squared is just 1. Plus x to the 4th. Well, how many x's do I have left here? I have 1, 2 after I pull out the x squared. So now I'm left with another x squared. Here, I had 9. I pulled 2 out. So now I have x to the 7th. Right? So that's what we mean by finding the greatest common factor. The greatest common factor of this is just x squared, right? It's the one thing that they have in common. When I want to factor it out, it just means that I have to pull x squared out of each component that's listed there. So we're going to do a few sample problems with the greatest common factor. So what if I had 12x minus 18? The first thing I'm going to do is I'm going to look at the numbers. Only one of them has an x value, so we can't pull a variable out. But I can look at 12, and I know that my screen is shrinking now. I got to make it big again. If I look at 12 and 18 and their factors, right, I go, okay, well, 12 has a factor of 1, 2 goes into it, 3 goes into it, 4 goes into it, 6 goes into it, and 12. Those are my only factors of 12. My factors of 18, I've got 1, 2, 3, 4 doesn't go in, 5 doesn't go in, 6 does, 9 does, and then 18 does. And And so I'm going to look at this and go, well, what is the greatest number that they have in common? And in this case, it's going to be 6. So the greatest common factor numerically of these is 6. So I would factor out 6 from each piece. 12 divided by 6 is 2. I can't do anything with the x value, so it just stays there. Minus 18 divided by 6. 18 divided by 6 is 3. And we have factored this expression, right? Let's look at another example. What if I have 40 x to the 8th y plus 64 x to the 4th, pen froze there, x to the 4th, y. And I want to factor out the greatest common factor of these. Now, I look at 40 and 64, and I know that they're each divisible by 8, and I think that might be the greatest common factor. But what if I don't know? Well, if I don't know, I'm just going to break down all the factors of 40, right? Which would be 1 goes in, 2 goes in, 4, 5, 6 go in, no, 7, no, 8, yes, 8 times 5, 10, 20, and 40, right? Those are all of my factors of 40. I'm going to do the same thing for 64. I'm going to go 1, 2, 3, no, 4, no, 4, yes, 5, no, 6, no, 7, no, 8, yep, 8 times 8, right? So looking at this right now, I already know that 8 is going to be the greatest common factor. I could finish these off. 4 times what equals 64? 16. 2 times 32 and 64 itself, right? But I already know right now that the greatest number that they have in common with each other is 8. And so that's what I can pull out. What if you don't know it and you don't feel like breaking this all down? Well, you know everything here is divisible by 2. Each of those numbers are divisible by 2. So then you'd wind up with 20 and 32, and you could look at that and go, oh, those are divisible by 2 as well, and you could do it that way, but it's a long process getting there. I like to think of it in terms of the biggest number I can pull out of it. But so we know, what do we know? We know that we can pull out an 8. Here I have 8 x's and here I have 4 x's, which means I can pull 4 x's out because each piece has at least 4 x's. Each piece also has one y value, so I can also pull out the y. Right? That is the greatest common factor. All those pieces together are my greatest common factor that I can pull out of this expression. And I can go, okay, well, 40 divided by 8 is 5, so that's going to be 5. I'm going to have 4 x's left because I took 4 x's away, and I'm not going to have any y's because I pulled out the only y I had. Plus 64 divided by 8, well, that's just 8. I pulled out the 4 x's, and I pulled out the y. And so that is my factored expression. Right? I factored it out to its simplest, most basic form. So that's your general rundown. With that and the examples that we're doing in class should get you through it. The last thing I want to talk to you guys about is factoring trinomials. And today we're only talking about trinomials, factoring trinomials. Today we're only talking about trinomials where a, so if we have ax squared plus bx plus c, we only want trinomials where the a value equals 1, right? And I have this little chart that I use when I'm dealing with those kind of expressions, and you'll see it during your class, but you'll also see it here to kind of understand what those factors are going to look like. So if I have ax squared plus bx plus c, I know that my factors are all going to be positive. I'm going to have x plus something times x plus something else. If I have ax squared minus bx plus c, I know that my factors are going to be x minus something, x minus something else. If I have ax squared plus bx minus c, we're going to have x plus something, x minus something. And same if we have ax squared minus bx minus c, we're still going to have x minus something times x, x plus something times x minus something. In the last two, which factors are negative and which factors are positive all depends on the sign in front of b. So if our b expression is positive, our bigger factor will go to the positive and our smaller factor will go to the negative. If our b is negative, right, like we have here, the smaller factor will go to the positive and the larger factor will go to the negative. And I'll give you a couple examples of that. I won't spend too much time on it because you're going to get a little of this in class, but you're also going to get a little of this in your homework. So a few examples of this I would have. If I have x squared plus 14x plus 45. I know that my factors are going to be x plus something and x minus something. The steps that you take to figure out what those somethings are is you are going to take your C value, you're going to find the factors of your C value. Oops. That add up to your B value. What does that mean? It means exactly what I said. So we're going to look at what are our factors of 45, right? Our C value is 45, right? Our A is 1. Our B, right? This is our A. Our B is 14. Our C is 45. So we're going to take the factors of our C value, which is 45. And we've got what? 1 and 45. 2, no. 3, yeah, 3 goes into it. 3 and 15. 5 and 9. And I believe that is it, right? Those are pretty much all of our factors of 45. So we're going to look at these factors and we're going to go, which ones add up to 40 to 14? If I add 1 and 45, I get 46. If I add 3 and 15, I get 18. If I add 5 and 9, I get 14. So these are the factors that we can put into the boxes here, or the parentheses, right? These are our factors of this expression. You can always tell if you're right if you want to distribute that out, right? If I chose to distribute these out just to see, I could go, well, x times x is x squared, and x times -9 is -9x. 5 times x equals 5x, and 5 times -9 equals negative. Oh, sorry, it's supposed to be positive. Everything there is positive. I don't know why I had a negative there. Plus 45, right? And when I combine my like terms, I wind up with x squared sorry, this was plus because I screwed up, plus 14x plus 45, right? And we wind up with the same equation we were left with. I don't know why I put in a negative here. I said as I was writing it that it was going to be positive. So you can always go back and check if you multiply them together. If you do that distribution and you multiply them together, you should get the same response back. Let's look at a different example. Let's look at it in a different color because that light blue does not show up so well. Let's look at k squared plus 2k minus 48. The one thing I know about this is that I'm going to have a k plus something, and I'm going to have a k minus something, right? We can go and check our chart that we made up above, right? I have a minus c in it, so I know I'm going to have a positive and a negative factor. So let's look at our factors of 48, right? It's negative 48, so we know one factor has to be negative and one factor has to be positive. And in this case, because we have a plus, we know it's our bigger factor that will be positive. So I'm going to go, I've got -1 and 48. I've got -2 and 24. I've got -3 goes in 1/16. I've got -4 and 12. I've got -7, 8. Does 8 go in? 9. Trying to think of all my factors. -6, right? And 8. I believe those are all of my factors, right? Because 12 we've already gotten to. So I'm going to look at these now and I'm going to go, which of these add up to 2? So 48 minus 1, minus 1 plus 48 is just 47, right? Minus 2 plus 24 is 22. Minus 3 plus 16, well, that's just 13. Minus 4 plus 12, that's 8. And then we've got minus 6 plus 8, which is 2. Now, you don't have to do all this side work. I'm just kind of showing you how it works. You're more than welcome, if you could figure that in your head, to go and figure it out in your head. What we want to look at here is, where do we put these? Well, we've got the negative in front of 6, so let's put it in the negative box. We have the positive at 8, so let's put it in there. These are our factors. If we wanted to, we could distribute them out, figure that out, right? So just follow the examples in the chart and you will know how to set up your parentheses, your factors, your parentheses, right? And then you can go ahead and just find the factors of whatever your C value is and put it into your parentheses for your factors. Why do we do this? Ultimately, we do it because that's how we find the solutions, or what we call the roots of quadratics. These trinomials that we've been working on are quadratics. Excuse me. Hopefully that's enough examples for you to get through the homework. If it's not, please let me know. You'll have one to do in the Edpuzzle on your own before you can move on. But let me know if you have any questions along the way, and I will see you in class.